Namaste. Good morning. Today, now let us see geometric progression. Geometric progression, you have learned the arithmetic progression. Now let us see some examples. In this, some examples of sequences like this. First, now consider 2, 4, 2, 4, 8, 16 and so on. 2, 4, 16 and so on. In this, now if you consider A1 is 2, A1 is 2 and A2 is what? 4. So now here A2 by A1, that is 4 by 2, you get the 2. You get here 2. In the same way, now if you consider A4 by 3, here you consider A4 by 3, then A4 is what? 16 and A3 is what? 8. So now you get 2. In this, in each case, if you divide the succeeding term by its preceding, then you get 2. 2 is a constant. The 2 is constant ratio. So this 2 is a constant, and this 2 is known as the, here 2 is a constant, here 2 is a constant ratio, known as common ratio. In this common ratio, now consider the another example. Now we consider the 1 by 3. Now consider this first example. Now consider this as A, example A. Now consider another example B. So now consider 1 by 3, 1 by 9, 1 by 9 and 1 by 27, 1 by 27 and 1 by 243, 1 by 27, 1 by 2, 1 by 27 and 1 by 28 and so on. So now you consider in this way. Now we consider the another example in this way. So now if you consider another example, so now in this, if you divide this A2 by A1, so now you divide A2 by A1, then you get 1 by 3. Now if you divide A2 by A1, 1 by 9 and 1 by 3, you get 1 by 3. And you divide this A4 by A3, then you get 1 by 3. Here is what? We get 1 by 3. So 1 by 3 here Here 1 by 3 is common ratio. 1 by 3 is common ratio. The such sequences are called geometrical sequences. Such sequences are called geometrical sequences. So now such sequences are called what? Geometrical sequences. And such type of progression sequences are geometrical progression. So now we can define the geometrical progression, a sequences. Here we can define a geometrical progression. A sequence A1, A2, A3, An. A sequence A1, A2, A3, An is called GP if each term is non-zero, if each term is non-zero and ek plus 1 upon e. If the succeeding term divided by the preceding term. Succeeding term is divided by the preceding term, then you get a constant. Then you get the constant R, and this key is greater than equal to 1 for k is greater than equal to 1, per k is greater than equal to 1. This type of sequences is called GP. The such sequences, what? Such sequences is called this type of sequences. This type of sequences is called in GP. Standard form of geometrical progression. If A is the first term, standard form of GP if first term is A and common ratio is R. If common ratio is R, then AR square in this way and so on, and the nth term ARn minus 1. The ARn minus 1 first term is A, second term AR2 minus 1, third term AR3 minus 1, and nth term ARn minus 1, the nth term of GP, we can express this as An, that is what? ARn minus 1. The An is what? ARn minus 1. It is same as nth term of GP. Nth term of GP, we can write the nth term of GP. The nth term of GP is what? ARn minus 1. In this way, you can write the nth term of GP ARn minus 1. Let us see how you find the sum to n term of GP. To find the sum of n term of GP, sum to n term of GP. If A is the first term, consider E. Consider A is the first term. A is the first term and R is the common ratio, and Sn is the sum of first n terms AR square and so on ARn minus 1. To find the sum of first n terms to AP, now there is the two case. First, if R equal to 1, case 1. Now in the case 1, first consider the case 1 if R equal to 1. If R equal to 1, then you get Sn equal to what? A plus A plus A. That is up to n terms, A plus A plus A and so on up to the n terms. Up to the n terms. That will be, you get what? That is the n terms plus A up to the n terms. So we get N A. We get this N A. So this is the first case. And case 2. Now consider the case 2. If R is not equal to 1. So if R is not equal to 1, then we multiply in this the equation, multiply in 1. So now if R is not equal to 1, then multiply R in 1. So then R Sn equal to AR plus AR square plus AR cube and so on. You get AR to the power and this will be second. So now this will be second. Subtract the second from the first. So now we subtract second from first. Subtract subtract equation second from first. We get subtract second from the first. So now we subtract the second from the first. We get 1 minus r Sn. 1 minus r Sn. So 1 minus r Sn, this will be equal to, now here you see, here you get ar square, ar cube, ar n minus 1. Each of them will be cancelled. We get a minus a r to the power n. So we get only these two terms. Then you get here what? Sn. We get Sn equal to a 1 minus r to the power n, that is 1 minus r. R, here you get a r to the power n minus 1 upon r minus 1. If r is greater than equal to, if r is greater than 1. So that is the sum of n geometrical mean if r is not equal to 1. So if r is not equal to 1, this is the if r is not equal to 1. So this is the sum of first and geometrical and sum to n geometrical, sum to n terms of a GP. So this is the sum of n terms to a GP. Now let us see geometric mean. Let us see geometric mean. This will be the sum of Sn, sum of n geometrical n terms of a GP. Let us see geometrical mean. Look at the geometric mean. Let us see the geometric mean. Now in the geometric mean, that is known as the geometric mean. This will be also known as the GM. Geometric mean, GM. Let A and B are two numbers and G is the geometric mean between two numbers. Let A and B are two numbers and G is the geometric mean between two numbers and G is the geometric mean between G is the geometric mean between two numbers, then A, G and B. A, G and B forms the geometric progression. If A, G and B form the geometric progression, then what happens? If A, B and G form the geometric progression, then what happens? That is the G. Here G by A equal to B by G. This is the common ratio, and common ratio is the same. So now you know that what? You know that common ratio is the same. So now you know that the common ratio is the same. Therefore, this implies that what? G square equal to AB. This implies that G equal to under root AB. So this is the geometric mean between two numbers. The geometric mean between two numbers is the square root of the product of two numbers. Now let us see how you inserting n geometric mean between two numbers. So let us see how you inserting n geometric mean between two numbers. So now let us see n geometric mean. How you find n geometric mean between two numbers? N geometric mean between n geometric mean between two numbers. So now let us see how you find the n geometric mean between two numbers. So let A and B are two numbers and G is the and two numbers, and there are n geometric mean. There are n geometric mean between two numbers. Let A G1, G2, G3 and so on, Gn and B. There are n geometric mean between these numbers. If there are n geometric mean between these numbers, then what happens? B is the n by 2th term. The B is the n by 2th term. Here B is the n plus 2th term. The B is the n plus 2th term. The B is n plus 2th term. Therefore, B is the n plus 2th term. So that what? B equal to AR n plus 2 minus 1. This will be AR n plus 1. So this will be AR n plus 1. So that is R. What happened? R equal to B by A 1 upon n plus 1. So this is the B. So now if you can find the common ratio R, then you can find G. The G1 is what? G1 is first term first term is A, then G1 our G1 is what? Here is the G1. Our G1 is what? G1, you can find G1 is AR. The AR, you can find A and R. R is given B by A 1 upon N plus 1. You find G2. G2 is AR square. You find A B by A 2 N plus 1. And G3 you can find AR cube. You can find A B by A 3 N plus 1. In this way you can inserting and geometric mean Gn AR to the power n. You can find this. So that is the A B by A n upon n plus 1. In this way you can inserting and geometric mean between the two numbers. Okay. Now let us see relation between arithmetic mean and the geometric mean. So now next, relationship. Now let us see relationship between arithmetic mean and geometric mean. So now let us see relationship between arithmetic mean and geometric mean between the two numbers. The arithmetic mean, now let arithmetic mean denoted as A, arithmetic mean denoted with letter A, so that is A plus B by 2. And geometric mean denoted as G, so this will be root AB between two numbers. This is arithmetic mean and the geometric mean. So now E, consider here, you consider A minus G. A minus G, so that is A plus B by 2 minus root AB. So we can write this what? A plus B minus 2 root AB upon 2. So we can write this root A minus root B whole square upon 2. This upon 2. And now here you see, this is the square. This will be what? This will be the square. The square of a number is always positive. So that this will be the greater than equal to 0. Always greater than equal to 0. So that what happens? A minus G is always greater than equal to 0. So this implies that what? Arithmetic mean is always greater than equal to geometric mean. So now remember this, arithmetic mean is always greater than equal to their geometric mean. The arithmetic mean is always greater than equal to the geometric mean. So now let us see some of the problem. Exercise 9.3. Question number 3, exercise 9.3. In this, it will be given fifth term. Fifth term of a GP is given A5. A5 is given. The fifth term of GP means AR to the power 4. That will be given P. The fifth term of a GP is given P. Earth term of a given GP, earth term A8 means AR7. This will be given Q. And 11th term is given 11 A11. This will be given AR to the power 10 S. This will be given S. Then prove that Q square equal to PS. Then prove that what? Prove that Q square equal to PS. So to prove that Q square equal to PS, now let us see Q square. Here Q square is, prove that Q square is PS. Now from right hand side PS. To write the value of PS, P is AR to the power 4, and S AR to the power 10. AR to the power 10, this will be A square, and R to the power 14. This will be A, and this will be what? A square R to the power 7 whole square. So this A square R to the power 7 whole square. This is A R to the power 7 whole square. So this AR to the power 7, AR to the power 7, the place of AR to the power 7 you can write what? Q. So this will be Q square. Therefore Q square equal to PS. So now we have proved Q square equal to PS. In this way, we can prove the Q square equal to PS. Now in this, the sum of first three term of a GP is 39 by 10. The sum of first three term of a GP. So now let the three term of, let three term of a GP, or let the first three term of a GP are what? A by R, A R. And the first three term of a GP is given 39 by 10. So this will be given 39 by 10, A by R plus AR square AR. This will be given 39 by 10. The first three term of a GP is 39 by 10 and their product will be equal to 1. So this is the first and their product of these three, AR into AR. This will be given 1. So now from this RR is cancelled. Here you get AQ equal to 1. So this implied that what? This implied that A equal to 1. So from this we can get A equal to 1. So now put the value of A equal to 1 in 1. Putting the value of A equal to 1 in equation 1. We get what? 1 by R plus 1 plus R equal to 39 by 10. Now multiply in this by 10R, then you get, now multiply in this by R, 10R, then you get 10 plus, here you get 10R plus 10R square equal to 39R. So 39R, that is 29R. Now R 10R square minus 29R and plus 10 equal to 0. Plus 10 equal to 0. So now if you simplify this, then you can get 10R square. Here we simplify this, so you get 10R square minus 25R minus 4R plus 10 equal to 0. Take the common, here 2R, you get, here you get 5R, you get here common 2R minus 5 and here you get 2 common, the 2R minus 5 equal to 0. Here from this implied that what? R equal to 2 by 5 and R equal to 5 by 2. If r equal to 2 by 5, then you get all three are term here. Terms are what? First term you get a equal to 1, say a by r, 1 upon 2 by r, you get 5 by 2. And if you get this 5 by 2, here the 5 by 2, you get the term is what? 2 by 5, 2 by 5, 1, 2 by 5, 1 and 5 by 2. Or you get 5 by 2, 1, 2 by 5. So you get this. Okay? So now in this way we can solve. We see the next question the next time. Thank you.